Finger version 4. I think I have a video for version 1, 2, 3, and now it's 4, or rather hand. So this is just like, I think exactly version 3 with some small modifications, because I just moved, so the 3D printer might be out of calibration, and also I've changed the printer settings so that like tolerance, that stuff, so that it will print on any other printers. In the model, I can set it to like more actual hole size rather than the adjusted size, especially for that Ender 3 printer. Yeah, so that's the change, and to verify that it's still working, I printed this finger, and like it's working fine. Yep. So after that, I spent some time modeling the rest of the 3 fingers and also the palm section to get this one. So for this part, these are the printing place section. So you can see there are 2 screws connecting the lower part of the palm. So these are printing place, and basically I spent this is a 9-hour print, so I spent the night doing that, and the second day I've designed the rest of the palm to actually drive the fingers. Yeah. So on the driving side, I'm using a servo, but you can see like with this arm, it's not fully retracted. This servo still need to spin like this much to get the cable all tightened. Yeah, and this is a 15 millimeter arm, so like about 30 millimeters of travel is not enough. The cable is longer than that. Yeah, but I don't think this is a huge problem. Like, even if needed, I can modify the servo so to make it like multi-term. Also, I'm hesitating. I haven't tested the motor yet, but I think like 15 millimeter arm might not be powerful enough to like do any actual stuff. It surely will drive the finger, but like for example, when you are trying to hold something, I don't think this is powerful enough. So like the idea is to make it smaller but multi-term. Yeah, that's not a big issue. The more important one is the other side. So like for finger 1, 2, 3, I was using these kind of elastic bands to retract the fingers. They work fine, but the thing about these elastic bands are like they are not linear. When they are fully extended, they have a great force, but like when they retract a bit, the force gradually becomes 0. That's... Oh, I'm getting confused. But anyway, I remember like from my physics class that these things are not like springs, which has a constant like coefficient k. So like force equals kx, right? So, and also I cannot really adjust these elastic bands after they are mounted, or like as they are, because like it's fixed by its nature. So I don't have much control over it. So now I'm thinking that like I'm more preferring to using sprints. But the issue of sprint is that like for elastic bands, they will contract all the way. So like these are actual like usable or effective distance. So I can mount it like on these ends. I can even make the ends here. And that will work, but with sprints. Because it has to be mounted externally. I need to allocate extra space for it to expand and contract, not within the fingers. Actually, thinking about that might be a valid idea to put sprints here. But anyway, it's too hard to do. So I need to allocate space for the spring. And now with this kind of spring, this slot is, I think, 30 millimeter. That's definitely not enough. And I have drilled another hole, which is like about 45 millimeter. And now that is not enough. It can only support like 2 joints spanning, and that's reached to the end. So I'm not sure how am I supposed to mount, like which one should I choose. For next version, I'm preferring to using sprints, but the length could be an issue. Okay, anyway, I will update the CAD using the sprint model, and like even if this one does not work, I can always switch back to elastic bands. Yeah. Oh, and also another update. Okay, thumb. Firstly, the thumb. I didn't include that in this design. It's only 4 fingers. So thumb. I'm now thinking that we have, like for resting position, we place it 45 degrees with respect to other fingers. And there are 2 joints. And also we place a vertical joint here so that the thumb will like bend here. And thus we are able to grab stuff. And ideally the rotational axis of this thing should be slightly slanted, like about here, because like our human fingers, it's like from here to here, roughly. So that's like when rotated, the thumb can be parallel with the rest of the fingers, and we can do stuff like this. But that's too hard to draw. I will leave that to future versions, and for now, I think this one would work. Like after folding it, it will like this, which is still possible to grab stuff. Yeah. And also for mounting servo mounts, like originally I was thinking to place all the servos in the palm here to drive all the fingers, so that the hand will be a standalone module and independent to the rest of the arm. But now, because we have 4 servos for these 4 fingers, and also 2 for the thumb, there's not enough space to stuff all the things. Even if it is, it's too hard to model. So the plan now is to put all the servo in the arm, like most of the 3D print hand projects. Which means we cannot put the Z-axis, like to make the hand move this, like this axis here at the wrist. Otherwise, the cables won't pass through or like it's so hard to pass through. So because of that, I'm moving the z-axis to the end of the arm. And thinking about that, I might as well like move all the z-axis to the upper side of the limb. So putting z-axis here and here, rather than here and here, because like it helps with center of mass and thus rotational inertia and thus like faster moving actions, and also less force on each rotational joint. For example, here the mass will be more to the axis. Yeah, so that's the plan. I'm going to delete these two slots here, but add the slot for the spring like this, but like longer, and make the entire hand print in place. I hope my 3D printer will fit. Yeah, it will fit. Wait, is it? Okay, let's try. We can like add, at worst we can print it like 45 degrees. Okay, so that's the update. I think this one already is already looking pretty promising. Yeah. Okay, see ya. Hopefully I can print this tonight and get the final product tomorrow. Yeah, see ya.